Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. In this module, we are going to study about the introduction to ILS, localizer, glide path or slope, approach lighting system. Instrument Landing System ILS. It is a ground-based instrument approach system that provides precision guidance to an aircraft approaching and landing on a runway using a combination of radio signal and in many cases high-intensity lightning arrays to enable a safe landing during instrument meteorological condition IMC such as low ceiling and reduced visibility due to fog, rain or blowing snow. ILS consists of localizer, glide path or slope, marker beacon and approach lighting system. Have a look at the picture of the instrument landing system. Localizer. It is one of the main components of ILS which handles the guidance in the horizontal plane. The localizer is a VHF radio transmitter and the antenna system using the same range as VOR transmitter between 108.10 MHz and 111.95 MHz. Localizer frequency are only odd tenth with 50 kHz spacing between each frequency. The transmitter and antenna are on the center line at the opposite end of the runway from approach threshold. The localizer or VHF course maker emits two-directional radiation pattern. One comprises bearing of amplitude modulated wave with a harmonic signal frequency of 150 Hz and other one with the same amplitude modulated wave with a harmonic signal frequency of 90 Hz. These two directional radiation pattern do intersect and thus create a course plane or a horizontal axis of approach which basically represent an elongation of runway axis. The signal of localizer launches the vertical indicator called the track bar TB provided that the final approach occurs from south to north. An aircraft flying westward from runway axis is situated in an area modulated at 90 Hz, therefore the track bar is reflected to the right side. On the contrary, if the plane is positioned east from the runway axis, the 150 Hz modulated signal can cause track bar to lean out of the right side. In the area of intersection, both the signals affect the track bar, which causes a certain extent of deflection in the direction of stronger signal. Thus, if an aircraft flies roughly in the axis of approach, leaned out partially to the right of the track bar is going to deflect a bit to the left. Glide path or slope. Glide slope or angle of descent plane provides a vertical guidance for a pilot during an approach. It's created by a ground UHF transmitter containing an antenna system operating in the range of 329.30 to 335.00 MHz with a channel separation of 50 kHz. Like the signal of localizer, so does the signal of glide slope consist of two intersected radiation pattern modulated at 90 and 150 Hz. However, unlike the localizer, these signals are arranged on top of each other and emitted along the path of the approach. Marker beacon. Outer beacon. The outer marker is located 3.5 to 6 nm, 5.556 to 11.112 km from the runway threshold. Its beam intersects the glide slopes arrays at the altitude of approximately 1400 feet above the runway. It is also roughly marks the point at which an aircraft enters the glide slope under normal circumstances and represents the beginning of the final part of the landing approach. Middle beacon. The middle marker is used to mark a point of transition from an approach of instruments to a visual one. It's located about 0.5 to 0.8 nm, 926 to 1482 km from the runway threshold. When flying over it, the aircraft is an altitude of 200 to 250 feet, 60.96 to 76.2 above it. The audio signal is made up of two dashes or 6 dots per second. The frequency of identification tone is 1300 Hz. Passing over the middle marker is visually indicated by a bulb of amber or yellow color. Inner beacon. The middle marker emits an AM wave with a modulated frequency of 3000 Hz. The identification signal has a pattern of series of dots in frequency of 6 dots per second. The beacon is located 60 meters in front of the runway's threshold. Approach lighting system. It assists the pilot in transitioning from instrument to visual flight and to align the aircraft visually with the runway center line. Pilot approach at the approach lighting system at the decision altitude allows the pilot to continue descending towards the runway even if the runway or runway lights cannot be seen, since the ALS counts as the runway and environment. This was all about the ILS. Thank you.